The diagram shows the rectangle A and its enlargement B, so we can see A in the corner, B in the light purple, and it goes calculate the following. Write down the centre of enlargement. Now guys, the centre of enlargement is when you join a line, okay, so see the way I'm joining this corner into its equivalent corner. Keep going through it, okay, then join this corner to its equivalent corner, keep going through. Join this corner to its equivalent corner, keep going through. Now do you see where all the lines converge? That there is the centre of enlargement. Does that make sense? Alright, it'll make more sense on triangular objects, okay? So, what happens next, guys, is... I just got rid of them all.
Yeah.
It's here. These examples will come up and I'll do them as it happens, okay? Guys, next one, what's the scale factor of enlargement? Well, the small one has a length of 6, the large one has a length of 24. 6 plus 18. So it means the scale factor is 4. Calculate OT. Well, if this one here is 8 long, the other one has to be 4 times smaller, which will mean it's 2. And then it finally wants, what is the area of A divided by the area of B? Well, the area of A is 2 by 6, which is 12. The area of B is 24 by 8. What's 24 by 8? That's 24 by 8? Okay, I think it's 192. 192. What is 12 divided by 192? Sorry? 1 over 16. Now guys, is that what we're expecting? 1 over 16. Explain why. If the scale factor is 4, this means that the lengths are increased by 4 each time. This means that the area of B is going to be 4 squared times bigger. The area of B is 16 times bigger. Remember to square it when you know it's bigger, okay? Lads, can I see the homework of the two guys that left the room? Now, the next one is the triangle OAB is the image of the triangle OXY under the enlargement of centre O, with XY equal to 8, OX equal to 10, and AB equal to 18. Find the scale factor of the enlargement. So lads, what I've always told you from the very beginning of this is always draw the two triangles. You draw the two triangles, very little can go wrong. So that's OXY here, and then the other one is going to be OAB, which is the bigger one underneath. And then what we have is our 2, we'll put in our values. This is 10, this is 8, and then this one here is going to be 18. Now, we're going to compare the side 8 to 18. So 18 divided by 8. How much bigger is the big triangle than the small triangle? 2.25. Thank you very much, okay? 2.25 is the scale factor of the enlargement. Find XA. XA is here to here. But if we find the full length, we can just take away 10 from it. So multiply 10 by 2.25 and what do we get? Sorry? 22.5. Now the full thing is 22.5. What does that mean about XA? 12.5, because 10 plus 12.5 has to be 22.5. Finally, the area of the triangle OAB, which is the big triangle. The big triangle has an area of 101.25. What is the area of the small triangle? Now here's what it is, guys, right? What's the scale factor? 2.25. Now that is for lengths. That means a length of 5 will turn out 2.25 times bigger. However, for area, it's k squared. So what's 2.25 squared? That's probably too difficult to do in the mind, okay? It's going to be 5.0625. Now guys, this 5.0625 is how much times bigger the area is of the big triangle than the small triangle. So just divide it, exactly. 101.25 divided by that answer. Shh. Yeah. Okay, we get 20. So lads, the area of the small triangle is 20. Okay, we're going to continue. In this one, okay, enlarge the rectangle X by a scale factor of 2/3 about the origin. Label the image Y. Now, what it basically wants me to do is, it wants me to draw a rectangle that is 2/3 the size of the original rectangle. It means it has to be a smaller one. Now, start off with the first thing you do is this. You start off with each corner and bring it back to the origin. Okay? So, because this is where the centre of the enlargement has to be. Okay? Now, once I've done that, okay, next rectangle I draw has to be 2/3 the size of the original. Now, to estimate it, it's currently 3 blocks across. Okay? 3 blocks across and 6 blocks down. This means that my enlargement has to be 2/3 the size of the original, which is going to be 2 across, 4 down. Now let's see if I can fit across 2 across, 4 down anywhere. Okay, so I'm thinking I might go, just give me a quick sec, this has to be the lead one. 2 across, 4, yeah, so around here guys. Now, 4 down like so, 2 across, 4 down. Now, what I'm going to see here is, I'm just going to take out these points here for a second, if I can. I think it is meant to be up one. Okay, just give this a go again, guys. Shh. Okay. 2 across. I see it now. Okay, guys, here it is here. 2 across, 4 down. And as I said, it has to hit the same corners have to intersect. So, do you see now the way it's done? Do you see the way the line goes straight through each corner? So that's it there. 2 across, 4 down. It's like a projector. Lads, when you get in the way of the projector, it's basically like, it's exactly like a projector. So if I have 2 shapes, are you looking please? If I have this shape here, followed by this shape here, you can see that one of them is an enlargement on the other. Okay, and if I want to find out where is the centre of enlargement of this, what I'd have to do is the following. I'd have to, say what I said? Join at the sides, thank you. Okay, so what we do is this guys, 1, you join up the same side, the same corner with the same corner, and then you can join up this corner here with this corner here, and you can see that they all converge on 1 point. Okay, and now you can see that it looks a lot like an enlargement. That's what we did there on the board. Okay, so now that that's done, what we're going to do next is we're going to figure out, okay, that centre enlargement is done. We've labelled number Y is here, and goes, write down the ratio of the lengths of the sides of the rectangle X to the lengths of the sides of the rectangle of Y. Well, the length of X is 4. The length of Y is 4 and the length of X is 6. It's a 6 is to 4 ratio, which is the same thing as 3 is to 2. Okay, work out the ratio of the perimeter of X to the perimeter of Y. The perimeter of Y is going to be 2 plus 4 plus 2 plus another 4, which is 12. So that's the perimeter of Y. The perimeter of X is going to be 3 plus 6, which is 9, plus another 9, which is 18. It's going to be 18 is to 12, which is the same ratio, 3 is to. So what we've learned here is, guys, you're looking, perimeter is affected in the same way length is, because perimeter is one-dimensional. Okay? Now finally they're going to ask us about the area. The area, in my estimation, should be a ratio 9 is to 4. I got that by squaring 2 over 3 to get 4 over 9. One of them is 9 is to 4. So let's see if it works out that way. So guys, what's going to happen here is the area of this one is 6 by 3, which is 18. X is 18. And Y is going to be 4 by 2, which is 8. Divide both sides by 2 and we get 9 is to 4 as predicted. Okay guys, that's that question done. Next one on is going to be number 14, okay? Now number 14 shows the following. Phase A and phase B are similar, except one of them is a miniature version of the other. Okay? Phase A is 8 centimeters in height. The total surface area of phase A is 60, while the total surface area of phase B is 375. Now guys, area, one-dimensional or two-dimensional? Two-dimensional. Okay, now guys, if the scale factor is K, the way the area is affected is K squared. K squared is the amount the area is affected. So if you get the bigger area and divide it by the smaller area. So what's 375 divided by 60?
6.2.
It's around that, you're right, somewhere around there, okay? I think it's gone 6.25 probably.
Is it?
6.25, okay guys? Lads, K squared is 6.25. So the scale factor squared is 6.25. So what's the scale factor then? It's going to be the square root of 6.25. 2.5. It's not cut in half, it's square rooting it. Okay guys? Now what does that mean? If the scale factor is 2.5, what does that mean about the height of 8? It gets multiplied by 2.5. And it gets multiplied by 2.5, it turns into the height of 20. Okay guys, we'll stop it there for the time being. Alright.